All right, for our second video here, our second set, we've got Unit 2, Section 2, which is all about substitution. Substitution being a method of solving a system of equations in which one equation is solved for a variable, then this expression is plugged into the second equation. So we're getting one of our variables all alone, and then in the other equation, replacing that same variable with whatever it equaled in the other one. And you'll see what this looks like as we work through the examples. It's kind of an odd explanation. But so this is our basic set of steps here. Step one is as we take our system of equations, we solve one of the equations for one variable. Now, in many problems, this may already be done. If our system of equations already has one equation as y equals 3x plus 7, for example, in that case, y is already alone, so it's already solved for. Same thing if we had like x equals 3y plus 8. Again, x is already alone, so it's already solved for just for that one variable. So to boil down step one, essentially we're just saying get x or y all alone. Doesn't necessarily matter which one, whichever one is easiest to get alone. Okay, step two then is to plug the expression from step one into the other equation. So if I said, again, I have two equations in my system, one of them where y equals 3x plus 8. Then in the other equation, everywhere I see y, I just plug in 3x plus 8. Okay, I've literally just replaced that whole variable with an expression. Okay, so again, step two can boil down to replace a variable with an expression. And again, it's whatever variable you solved for or got alone in step one. Moving along, step three then says we're going to solve that equation from step two. So after step two, you should have kind of one big long equation that either only has x's, and constants, or it only has y's and constants. In either case, there should no longer be x and y in this equation. It should only be y's, or it should only be x's. And if you have only x's or only y's, then you can get that piece all alone and just say x equals some number, some constant, either x equals -7, or x equals 8, or x equals 42. Or if it was y's you were working with, same thing, y equals 17, whatever it is, you're going to solve for x or y. Get it all alone, so it's just that thing. So at this point, you've already solved half of your problem, or half of your solution. You found the x or the y value for the intersection. Now your last step, step four, you're going to substitute the value of the variable that you got from step three into either of the equations from the very beginning. So one of our original equations. When you substitute it in, you then solve for the other equation. So again, if I found out from step 3 that x equals 8, then again, I go back to one of my original equations, plug 8 in for x in every single spot, and then just solve for what y would be. So again, we can boil this one down to solve for the other variable. Whatever we got before, if we solved x equals 8, then we have to solve for y and say y equals 3 or whatever it is. So we've already solved for one, solved for the other. Okay, now let's take a look at what this actually looks like if we were going to go through and solve one of these. Okay, so we start with our system of equations right here. We have our two equations with two unknowns. They both have x and y as their variables. Now our first step is always to get y all alone. And if we look at this, y already is all alone. Okay, we don't have to go through any steps. Our step one is already done for us. Our two equations are y equals -4x plus 20 and 4x minus 2y equals 20. So our first one already has y alone for us. Now for step two, we're literally just plugging in this piece right here, this expression, that -4x plus 20, everywhere that we see y in the other equation. So right here, we take our 4x minus 2y equals 20 and instead say 4x minus 2 Here's what we plug in for y, that negative 4x plus 20 equals 20. So we plugged in everything from one equation into the other one. Now when we look at this, all we're working with is x's, or should I say x and constants, sorry. So in this case, we don't have y anymore. All there is x and numbers, so we can figure out what x is. So in this case, because we have this whole thing being plugged in as an expression, we have to do 2 times this whole piece, which means we're going to be doing a distributive property. So we would say 2, or, because it has the minus, think of it as negative 2 times negative 4, or times negative 4x, and negative 2 times 20. When we do that, we simplify our equation to say, and I'm going to put all of the x terms in blue, all of the constant terms in green, and all of the y terms in red from here on out. This 4x remains as 4x. Negative 2 times negative 4x becomes positive 8x. Again, this negative 2 times the positive 20 became a negative 40. 20 on the other side remained as 20. So that's where we got this new equation from. This 4x plus 8x plus negative 40 equals 20. Okay, now we need to work at getting x all alone. Okay, so I'm doing kind of 2 steps in one here. I combined all my x terms, 4x and 8x became 12x, and I also added 40 to both sides. I did have a negative 40 here on the left side before, so I added 40 to both sides, and that's where I got this 60 from. So my equation says 12x equals 60. From here, I'm trying to get x all alone, so I can divide both sides by 12. In fact, I'll write that in. Divide by 12, divide by 12. And now we can see that x equals 5. So that was my step 3, solve for x. We got x all alone by itself. We know for sure in our solution, our x value is going to be 5. Well, what can I do with that information? What can I say about x equaling 5? I can plug it in to my other equation then. So not the 4x minus 2y equals 20. I plug it into the top one, and we'd say y equals 4, or should I say negative 4, times x, which we figured out was 5. So negative 4 times 5, and then add 20. Now again, all we need to do is just simply solve each piece out. Negative 4 times 5 is going to be 20, or negative 20, because it's negative 4. And then we're still adding on the 20 from before. So y equals negative 20 plus positive 20. Well, negative 20 plus positive 20 is in fact 0. So y equals 0. So in this case, we can see our y value, y equals 0. Our x value, x equals 5. So moving these out of the way, we would say our solution, or the spot where these two lines intersect, is going to be at 5, 0. This is the spot, or this is the coordinate, where both lines intersect each other. Let's try another one, solving with substitution. In this case, we have our two equations, y equals negative 3x plus 5. And in our other one, we have y equals x minus 7. Now, step 1 says we need to get x or y all alone. Well, in either case, both of the equations we're looking at, y is already alone. So from there, we just, step 2, plug it in. In this case, you can see I plugged this piece, this negative 3x plus 5, whoops, smartboard getting a little off. This whole side, negative 3x plus 5, got plugged in for this y down here. So it says negative 3x plus 5 equals x minus 7. Now that I have plugged in one equation into the other, now there's no more y's, So I can just go through solving it. The steps I'm doing as I'm solving through this was a negative 3x, so I'm going to add 3x to both sides. When I add 3x, these ones go away. 1x and 3x becomes 4x. The 5 is left alone, and this negative 7, remember because it's minus 7, we can think of it as we're adding on a negative 7. So the negative 7 remains. At this point then, we have 5 equals 4x plus negative 7. Well, if I want to get x alone on both sides, I would add 7. So we have 5 plus 7 on one side, which becomes 12. This negative 7 and positive 7 go away, so we just have 12 equals 4x. Again, to get x all alone, divide both sides by 4. And we can see then that our last piece there, we would say x equals 3. So we know in our solution, the spot where these two lines intersect each other, the x part of that coordinate is going to be 3. What do I do with that piece, that x equals 3? Well, again, I plug it back into our original equations, one or the other. So I start with y equals, instead of x minus 7, I know x is 3, so I say y equals 3 minus 7. Carrying that through, I know that 3 minus 7 is negative 4. So we just say y equals negative 4. Now that I have my two pieces, my x and y, I would say my solution, in this case, the spot where both equations or both lines crosses at the same time, would be at 3, negative 4. X is 3, y is negative 4. So that is our one and only solution. Let's look at another example of substitution. In this case, I don't already have x or y all alone. I need to move things around in one of my equations to get there. So if we look at our two equations, I have 7x minus y equals 1 and negative x plus y equals negative 7. So in this case, I think I might use that bottom equation and try to get y alone, because in that case, it'd be just as simple as adding x. Okay, this negative x right here, I can just add that to both sides to get y alone. So I'll start off with negative x plus y equals negative 7. That was the original equation. Now I'm just adding x to both sides, which means that y equals that positive x now, because I added it, x plus negative 7. Now that I have y all alone on its own, I can work towards plugging it into the other equation to solve for my x. So instead of saying 7x minus y equals 1, I know that y over here equals x plus negative 7. So that's what I plugged in for y. So now I can say 7x minus x plus 7 equals 1. Again, because we have a minus out here, it's like we're taking negative 1 times each one of these pieces. So we have to distribute negative 1 to each of those pieces inside there. So this one becomes 7x plus negative x, because it's like negative 1 times x. So 7x plus negative x plus negative 1 times negative 7 would be a positive 7. So 7x plus negative x plus 7 equals 1. Okay. Now I can see I've got two different x terms, 7x and negative x, that I can combine together, and I can call those 6x. Okay, that negative x, again, is like a negative 1x. Negative 1 plus 7, because I'm combining them together, would be 6. So I have 6x plus 7 equals 1. To get rid of that extra constant term, I would just subtract 7 from both sides. When I do that, I'm left with 6x equals negative 6. From there, again, I just need to get x all alone. Divide by 6, divide by 6. And we can say that x equals negative 1. At this point, I have solved for x. We know in the solution the x term is going to be negative 1. So that was all part of our step 3, solving for x. Now that we have x all alone, we plug it into our other equation. I'm going to move this off to the side. Plug it into our other equation to solve for y. It's our step 4. So instead of saying negative x plus y equals negative 7, I'm now saying negative x, which is negative 1, so negative 1 plus y equals negative 7. Now a negative version of a negative, again, this is like putting a negative 1 times this piece here. Negative 1 times negative 1 is actually positive 1. So our equation now says positive 1 plus y equals negative 7. To get y alone, I'd have to subtract 1 from both sides to get rid of it. And so I can say y equals negative 8. So that's my y portion of the solution. Putting those two pieces together, we'd say the solution to this system, or the spot where both lines intersect each other, is at negative 1, negative 8. Or again, the spot that x is negative 1, y is negative 8. For our fourth example, again, we need to solve with substitution. In this case, again, normally we've been getting y alone. In this case, I think I can get x alone. I've got my two equations over here, my system, x minus 6y equals negative 20, and 5x plus 8y equals negative 24. I don't always have to just get y alone. I can get x alone too. And this is how it's going to work. I start with my equation that x minus 6y equals negative 20. And in this case, if I'm trying to get x alone, I would add 6y to both sides, because before I was subtracting it. And so now I'd have x equals 6y, or a positive 6y, because I added it on there. X equals 6y plus negative 20. Or if you want to say 6y minus 20, that's okay. I think it's easier to talk about it as adding a negative version. In this case, again, we have x is all alone, and it's solved for this piece, this expression. So that's what I'm going to use to plug into my other equation. So again, I have to plug it into the second one because we used the first one to solve. So instead of saying 5x plus 8y equals negative 24, I'm now saying 5 times the amount, 6y minus 20. That's what we found over here. 5 times 6y plus negative 20, all of that plus 8y equals negative 24. And again, because we have all of that expression being multiplied by 5, we have to distribute 5 times the 6y and 5 times this negative 20. In doing so, move this aside, 5 times 6y is going to be 30y. 5 times negative 20 is going to be negative 100. So we have 30y plus negative 100 plus 8y equals negative 24. To simplify this one, again, I have my 8y and my 30y, and I can just add them together. And that's where we got this 38y from. Moving even one step further, I can add that 100. It was a negative 100 before. Now I'm adding 100 to both sides. And that would leave us with 38y equals 76. Now, to get our y alone, we would divide both sides by 38. And in doing so, we get y equals 2. That was our step 3. We did all of that to solve for y. Now that we have y all alone, we can plug it back into our other equation, one of our original ones, and use y to solve for x. So instead of saying x minus 6y equals negative 20, I know y is 2, so I can say x minus 6 times 2 equals negative 20. When I do that, again, we think of this minus 6 as like a negative 6. So negative 6 times 2 would be a negative 12. So x plus negative 12, or you can think of it as x minus 12 equals negative 20. To get rid of that negative 12, I'm adding 12 to both sides. So I would have just simply x equals negative 8. Negative 20 plus 12 becomes negative 8. So now I have the x value of my solution. So moving this aside then, we can see my solution is going to be at where x is negative 8 and y is positive 2. That's going to be the one spot on the whole graph where both lines converge or intersect. For our last example, we have kind of a geometry problem to work with. It says we need to find x and y, and we know that y is going to be 10 less than x. Well, one thing we know about triangles is all of the inside angles have to add up to 180. And then this box right here means it's a right angle, which means that one is going to be 90. So we can say that y plus x plus 90 has to equal 180. And because we know that y is going to be 10 less than x, we can say y equals x minus 10. It's 10 less than x. Now, again, we need to get one of our pieces alone, and in this case, y is already alone. It's nice and easy. All we need to do is plug that piece, that x minus 10, in for y into our other equation. So instead of saying y plus x plus 90 equals 180, we now just plugged in this piece, x minus 10, and then continued from there. X minus 10 plus x plus 90 equals 180. From there now, we can combine some like terms and simplify as we go. I had x and x both being positive, so when I put them together, I have 2x. I had a negative 10 or a minus 10 and a positive 90, so those became positive 80. So that's where those pieces of my new equation came. 2x plus 80 equals 180. I can subtract 80 from both sides, which means I'm going to have 2x equals 100. We have all of our x's alone and our constants alone on the other side. And my last step is to divide 2 from both sides, and I would get x equals 50. Again, we've solved half of our solution. We know the x value where they are the same. Now we need to find the y value that would make them both the same. So I plug x equals 50 into one of our original equations. So instead of y equals x minus 10, I'm now saying y equals 50 minus 10. And of course, 50 minus 10 is just 40. So we have y equals 40. Move that piece out of our way. Our solution then would tell us that x is 50 and y is 40. So our coordinate point, if we were to graph these two equations on a grid or as lines, this would be the spot where they both converge or they both intersect. It's at the spot 50, 40. And that's going to wrap it up for substitution.